Hello guys, in this video we'll go over the questions found in your review for quadratics. Okay, question number 7. Label the following for the parabola on the right. So we need to know the characteristics of a parabola. Okay, so we're going to begin by the zeros. Zeros are x-intercept. So we need to look we need to find where the graph crosses the x-axis. So in this case, we're going to have this point right here and this one, okay? It crosses the x-axis twice, so we're going to have two zeros. The first one is the point -4, 0. And then the second one is a point -2, 0, okay? I'm writing the coordinate points. Now we need to find the y-intercept. And the y-intercept is when the parabola crosses the y-axis. So this right here is my y-intercept. And I need to write it as a coordinate point. The x value is 0 and the y value is 8. So 0, 8. Now we need to find the axis of symmetry. The axis of symmetry cuts the parabola in half. Okay? So if we have 2 points, we need to find the middle, okay? So this is where my quadratic formula is, okay? And remember that we need to write an equation, okay? X equals. Now, x is going to be equal to the number that the axis of symmetry crosses, okay? And in this example, it crosses -3. This right here is -3, okay? So x equals -3, okay? And we can actually check this by looking at our vertex, okay? Remember that the vertex is the minimum point or the maximum of our parabola. So in this case, since my parabola is opening up, okay, we're going to have a lowest point, which is this right here. And we need the actual order pair. The x value is -3. And then the y value is -1. So we can write -3, -1. And look, the axis of symmetry matches with the vertex. All right, we have a lowest point. So this right here is going to be my minimum. And now we need to find the domain. The domain for all my parabolas that have 2 arrows is all real numbers. So you can either use this R with 2 lines, or you can write all real numbers, okay? Now we need to find the range. The range is the y. So I'm going to begin by writing y. Now my parabola is opening up, so I need the greater than or equal inequality. And we are going to use the y value of our vertex. The y value is -1. So that means that y is greater than or equal -1. Okay, let's go with number 8. We need to find the same, the zeros, the y-intercept, and so on. So let's begin with the zeros. Zeros, again, are the x-intercepts. All right, so we're going to follow the parabola. The parabola touches the x-axis at this point right here. So this is going to be my x-intercept, and this time we only have 1, and the coordinate point is 0, 0. The y-intercept crosses the parabola on the y-axis, and look, it crosses it at the same place as we have the x-intercept. So our y-intercept is going to be the same, 0, 0. The axis of symmetry cuts the parabola in half, so my axis of symmetry is going to be the y-axis this time, okay? All right, it's this line right here. So we're going to write x equals. It crosses the x-axis at 0. And we can check that with our vertex, just like we did here. The vertex is the highest point or the lowest point. Over here, since my parabola is opening down, I have a highest point. So again, this is going to be my vertex. And the order pair again is 0, 0. And look, the x value is the same as my axis of symmetry. All right, I have a highest point, so I have a maximum. And again, my domain is going to be all real numbers. The domain is the same for all the parabolas that have two arrows. All real numbers. Now, the verbal description of the range. Okay, so this time I'm actually going to write the range, okay, with actual words. So on this side, I'm going to write it using inequalities, okay? So remember that we always use the y, okay? My parabola is opening down, so I'm going to have the less than or equal. And we're going to use the y value of our vertex, which is 0, okay? The y value. Okay, so if I read this, it says y is less than or equal to 0. When you write it, instead of using the variable y, we're going to use all real numbers. Okay, so we're going to say all real numbers are, what does inequality say? Less than or equal. Less than or equal what number? 0. Okay, so this is the verbal description of my range. Okay, question number 9. It says identify the following characteristics using the table. Okay. All right, so now we don't have a graph, we have a table. So we're going to begin with the zeros. Zeros is the same thing as x-intercept. And remember that your x-intercept, okay, is going to have a y value of 0. So I want you to look at this table, and we're going to look at the y. Do we have a 0? We don't, okay? We actually cannot see it. But in between what two numbers are you going to find the 0? Okay? Well, we're going to find it between 1 and -2, right? So for this problem, I am not going to write the zeros because it's not clearly given, okay? All right, and you can talk to this about this with your teacher if you have any further questions. Now we're going to go over the axis of symmetry, okay? But before we can find the axis of symmetry, we need to find the vertex. So I'm going to write here number 1. That's the first thing we need to find. Remember that the vertex, okay, is like a mirror, okay? The vertex is going to be between two numbers that are the same. All right, so let's take a look at, I'm going to start with -2. If we look at the number above -2 and below, are they the same? They're not the same. So -2 cannot be my vertex, okay? Now let's try -3. Is -2 the same as -2? Of course it is. So that means that this will be my vertex. So I'm going to highlight that, okay? And we're going to write that here. -2, -3, okay? Now that we have our vertex, we can find our axis of symmetry. Remember that the axis of symmetry is going to be x equals, and we're going to use the x value of our vertex, so x is equal -2. We're going to find the min or the max, so I'm just going to go ahead and make a quick sketch just so that I can check and see what my points are doing, okay? So I am going to label this right here so that it could be easier for us. So this will be -1, -2, -3, -4, and we have a 1, -1, -2, -3. Okay, I'm going to plot the points very quick. We have 0, 1, which is right here, 0, 1, this point. Then we have -1, -2, which is here. -2, -3, -3, -2, and then -4, 1. Okay, well, if you look at your dots and we just draw a quick line connecting them, what do we have? We have a minimum. Now, the minimum of the domain is going to be all real numbers, and then the verbal description of my range. Okay, now my range is going to be, we need to have a verbal description, okay? So I'm going to go ahead and write it out first just using inequalities. And we're going to use our vertex, okay? So we have y. Now from the sketch that we did, the parabola opens up. So it's greater than or equal. And then we're going to use the y value, which is -3, okay? So what we're going to do now is to write it in words. Remember that instead of just saying y, we're going to say all real numbers the inequality is greater than or equal what number? -3. And where does -3 come from? It comes from our vertex.
Hi, so this is your instructional video over your review part 2. We will begin with problem number 10. Let's identify the following characteristics of the quadratic parent function. Remember, the quadratic parent function looks something like this. The vertex is going to begin at 0, 0, and it's going to be going upwards, or what we call concave up. So the zeros is where it crosses the x-axis, or it could be called the x-intercept. This is going to be at 0, 0. So my x-intercepts or zeros are at 0, 0. My y-intercept is where it crosses the y-axis. It is also at 0, 0. The axis of symmetry, remember, is when it cuts the parabola in half. So it cuts it exactly at the vertex. So the vertex is at 0, 0 as well. It is a minimum. And remember, the x value is my axis of symmetry. So my axis of symmetry is x equals 0. Remember, in all quadratics, the domain is all real numbers. And then the range is y is greater than or equal to 0 because the y value matches the y value here in my vertex. So let's take a look at number 11. What is the equation of the axis of symmetry between the 2 points? So they're not actually asking you to draw the quadratic, but they're asking you to figure out where the axis of symmetry is. Remember, that cuts the picture in half. So if you look here, I have a dot here on the left. It is at 1, 3, and I have another dot here at 6, 3. So you should notice that they are equal distance to each other. They're 1 line, 2 line, 3, 4, 5 lines apart. So the axis of symmetry is going to cut this in half exactly. So it's going to be somewhere right here. So the axis of symmetry cuts this parabola in half. So it could either look something like this, or it could look something like this. We don't have enough information for us to actually draw it. All they want is the axis of symmetry. So the axis of symmetry is in between these 2 points. So it's going to be at 3.5. Question number 12. We're going to identify the maximum or minimum, and we're going to find the domain and the range. All right, so what I'm going to do is put this in the graphing calculator. And if you notice, this dot right here is the vertex. Do you remember, is this the minimum point or the maximum point? That's right. I'm going to take my calculator, 6, and this would be a minimum point because it's the lowest part of my parabola. So my vertex is at -3, -5. So this would be a minimum value. So that's the vertex. And now I'm ready to find the domain. Remember, the domain are all real numbers, and the range is the y value. So this is y is greater than or equal to -5. And that's where it meets. Number 13 says, describe the transformation of x squared to the new function. All right, x squared plus 1. So remember, the parent function always begins at 0, 0. So I'm going to type in my parent function, x squared, and it looks like this. So now I'm ready to type in the second. So now I have x squared plus 1. So what's the transformation? How did I get from my original to my second equation? That's right, the transformation is the vertex went up 1 unit. So that's the transformation. It went up 1. All right, so let's talk about the part B. So now I'm going to take my equation. I'm going to put in my parent function, because that's where we always begin. And this time I'm going to type in the second equation. Now this time I do need parentheses. That's the important part. So then now I'm going to type in x minus 2 close parentheses squared. Now what do you think is going to happen? Is it going to go left 2 units, right 2 units, up 2 units, or down? That's right, it went right 2 units. Remember, if your x is on the inside, your x always lies. So even though it says minus 2, you're actually going to the right 2. All right, problem number 14. So we're going to describe the transformation from the picture. So if you notice this picture right here, this parabola, this is my parent function. How do I know? It's because it has a vertex at 0, 0. So I know it has my parent function. So now I want to know how I get from my parent function to this function here. This is my new function. So what did I do? That's right. I went right. Now careful here. They are not counting by 2s. They are not counting by 1s. They're actually counting by 2s. So you actually went to the right 4 units. All right, so same thing with number 15. So if notice, this is my parent function. I know that because it begins at 0, 0, the vertex. And now I want to know the transformation. How did I get from 0, 0 to the vertex here in my second equation? Now careful here, they are again counting by 2s. So I went up 5 units. Alright, so now I'm ready to answer the multiple choice. So on problem number 14, since I went to the right 4 units, answer choice is D as in David, because I know my x always lies. And for number 15, it went up 5 units, so I know it has to be answer choice B as in boy, because the plus 5 is not inside the parentheses.